Hello, hello, hello. Hello, I hope everybody can hear me. Welcome, welcome, welcome. Okay. Welcome everybody to welcome to the Things Security webinar. This webinar is part of an online series of events leading up to the Things Conference in September. The Things Conference is the world's biggest event on LoRaWAN, with thousands of IT professionals joining and hundreds of speakers sharing the latest and greatest on LoRaWAN. The topic of the conference this year is digital transformation. And so we're going to be focusing all year on the ways that LoRaWAN data is making it directly into business processes and improving people's lives. Today is all about LoRaWAN security. So I'll try to pull up an agenda here and show you guys what we're going to cover today. Thanks again, everybody who's joining. Let's see. Okay. So today we're going to start off with a warm welcome. And I briefly discussed the Things Conference and the webinar series. And then I tried to condense Johan's big 1 hour in-depth LoRaWAN how-to into a 5-minute LoRaWAN security brief. And then we will cover some LoRaWAN security myths. And then finally, we'll do a Q&A with Adrian. So I hope that's exciting for everybody. And I figured out how to read comments in the chat. So if anybody has any questions, please drop them. And at the end, I hope that Adrian and I can address some of those questions. Okay. It looks like we have about 50 people here. Welcome everybody to the Things Security webinar. So we're going to get started here in a second. I'm going to show you a 5-minute video all about LoRaWAN security. And of course, this is just an introduction to LoRaWAN security. If you're interested in learning more about LoRaWAN, there's loads of resources online. And we're pretty proud of our the Things Network Learn section, where we've got all kinds of information about how to use LoRaWAN. And then we've also got the Things Network, the Things Stack Community Edition from the Things Network, where you can actually, once you've learned how to use LoRaWAN, go about implementing your own LoRaWAN solutions. So without further ado, I'm going to go ahead and play the Things. I'm going to go ahead and play the Things Fundamentals on LoRaWAN Security in 5 minutes. Let's get started. Welcome to the Things Fundamentals on LoRaWAN Security. Today, we'll discuss how LoRaWAN messages are encrypted and what that means for your application data, how to securely and scalably onboard LoRaWAN devices, and other best practices for building secure LoRaWAN networks. Of course, I'll also share some more resources so you can keep learning and get started building your own LoRaWAN solutions. I'm Ben, I'm the technical writer at the Things Industries. Let's get started. Today, I'll quickly remind you why LoRaWAN is awesome. I'll discuss the pillars of internet security. We'll talk about the different layers of security in LoRaWAN and what a session is. Then, we'll discuss activation, join servers, and finally, we'll discuss some best practices for implementing secure LoRaWAN networks. So again, why LoRaWAN is so awesome? Lots of reasons, and one of them, as you can see, is end-to-end security. LoRaWAN was designed from the ground up to be secure. Authentication and encryption are mandatory in LoRaWAN implementations, using modern 128-bit AES encryption. Implementation matters, though. A secure protocol doesn't protect against a person exposing root keys in plain text, or poor implementation which reuses simple root keys. LoRaWAN implements two-layer security, using separate keys for the application and network. This means that the application data which the end user sees is encrypted inside the network layer and cannot be accessed without that separate key. Encryption of LoRaWAN packets looks like an onion. In the middle, you have data, say a temperature or a button press. When a device or application communicates, that data gets encrypted by the application. Then, it gets encrypted by the network. Then, it might also get encrypted by the protocol it's traveling on, say HTTPS with TLS. It's important to note that once the network encrypts the data, it is totally secure. and additional layers do not really protect the message more. They just prevent attacks on that medium, like replays. The physical layer that LoRaWAN travels on, LoRa, has no security built in. All the security is implemented in the software LoRaWAN layer. The physical layer just has a CRC to detect errors. All of this encryption produces what's called a session. The network session allows the network to locate the device, and the application session tracks the number of messages and provides the last level of encryption. There are two ways to activate a device and create a session. Over-the-air activation involves storing root keys in the device and network, which are then used to negotiate new session keys for each session. Activation by personalization involves hard-coding session keys into the devices so they can never change. This is done in some cases to avoid having to negotiate keys, but it has several drawbacks. Over-the-air activation is more secure because new session keys are negotiated between the device and the network for each session. Since ABP involves hard-coding these session keys, if they are compromised, all future and past traffic is also compromised. There have been papers published in which poor ABP implementations, which reused keys, were exploited when attackers listened to an ABP message in one location and then played it back for other devices which used the same keys. Again, implementation matters for security. For example, it's important to use a secure connection between the network server and the end application. It's also important to know what information is not encrypted. During a join procedure, join EUI and dev EUI are transmitted publicly. This means that an attacker could figure out where your root keys are stored by the join IP address. So it's important that that's secure. The dev EUI may indicate the module and version of your device. If you're using over-the-air activation, you need a secure way to share root keys in the device with the network. The best way to do this is with a trusted join server. A join server allows the device manufacturer to securely share device root keys, and the join server then generates session keys, which can be shared with the network to authenticate a device without ever compromising those root keys. LoRaWAN has some more security filters built in. Message confirmation assures that packets are being received, and frame counters prevent replay attacks, for example. Finally, here are some tips for implementing secure LoRaWAN networks. Never expose root keys, and do not reuse keys for multiple devices. Using over-the-air activation and a join server allows for flexible, secure device activation. Now that you're a LoRaWAN security expert, let's talk about getting started. To prototype your first LoRaWAN solution, we recommend the Things Network, where you can use the free The Things Stack Community Edition, which has coverage from tens of thousands of gateways all over the world. Once you're ready to scale your solution commercially, reach out to the Things Industries for an SLA-backed, enterprise-grade, private LoRaWAN deployment, either in the cloud or on your own hardware. Thanks for watching. Okay, so that was LoRaWAN security condensed into 5 minutes. If you are interested in learning more about LoRaWAN security, I highly recommend heading over to the Things Network Learn section. That's the URL down there. And there's loads and loads of information so that you can figure out about just about everything that there is to know about LoRaWAN. And then there's also a certifications program. So if you're interested in showing off your knowledge, you can take a test and then you get a badge demonstrating that you've proved your knowledge in LoRaWAN. Up next, we have Adrian. Sorry. Up next, we have Adrian on to talk about. Oh, excuse me. Sorry. Okay, here. So up next, Adrian is coming on to discuss LoRaWAN security myths, and then we're going to get on together and try to answer some of your questions. So if you have any questions about LoRaWAN security, please drop them in the chat, and then we will try to address them. Adrian, I hope you're ready. Okay, let's see. Here we go.
Hey, everyone.
Hey, Adrian.
Hope you can hear me. Hey.
Yeah, I can hear you. So Adrian is a stack engineer at the Things Industries, and he is, by virtue of having worked on the LoRaWAN stack for so long, quite an expert in LoRaWAN security. And so I'm going to ask him some questions about LoRaWAN security myths. I'm going to ask him some questions about LoRaWAN security best practices, and then we're going to try to answer your questions. So let me pull some up. And okay, so I tried to make a big list of things that people might be interested in, and then at the end we will go and pick questions from the chat. So Adrian,
all yours.
Okay, a question that a lot of people ask, obviously, is about device activation. So what do you have to say about how to securely activate LoRaWAN devices?
Always go for over-the-air activation. Fundamentally, this is more secure and allows you more flexibility when it comes, for example, to moving between networks. So you discussed during your 5-minute presentation about this idea of ABP activation by personalization, in which the keys, the session keys, are embedded into the end device. The problem when you do this is that if you ever have to move the end device to another network, you have to migrate perhaps between providers, simply changing the place where your device runs in the cloud, let's say. Your previous traffic actually the previous host can look into your traffic fundamentally. So the keys are the same. Future traffic is going to be encrypted with them as well. Ergo, it can be read. So, and this is something that can be exploited. Another use case that can be dangerous, as you mentioned, is replay. So, for example, if the same ABP session is shared by multiple end devices, for example, a common use case for this is, let's say, street lights. So you have a full street, you have the lights each every couple of meters or whatever that is, and you use a single LoRaWAN command to actually turn on or turn off the end devices. Because the session is shared, you could basically listen to the command being given when the lights turn on, and then you could play it again in another place, play it again on another street or whatsoever, and control those lights. And this is something that it's a common use case which one should have in mind, that it's not a very good idea to bake in those keys into the devices. Instead, go for OTAA, control your end devices ahead of time, so have scheduling inside of them, get the ability to actually tell the device, hey, in a number of seconds you have to turn on when it comes to lights. Do make all that is possible such that you don't have to reuse the security session. Go for OTA and you will be way more secure and scalable.
Okay, great. So tip number one is use over-the-air activation. And I think that's quite related to then a join server. So can you tell us how a join server can help make a LoRaWAN deployment more secure?
Yeah. So the join server is used for the generation of, for the storage of the root keys, the keys that basically are used to derive your session keys that basically encrypt a current device session. And the idea behind the join server is that you no longer have to actually transfer those keys between your device manufacturer and the end consumer of the end device, and also that your root keys never actually leave a secure environment. So for someone, if they were to receive their card, their actual, let's say, Visa card, and their actual PIN via physical mail in the same mail, they would find it quite absurd because anyone could open the letter and could look into it. Yet when it comes to device keys, this is actually a quite common operation. You receive by email in plain text all of the keys for your end devices, and that's acceptable, but it's not secure. Fundamentally, sending keys in plain text should never occur. The good way of doing this is that your manufacturer has provisioned all of those root keys into a join server, and then while the device attempts to join, the network is exposed only to the session keys, and the root keys never leave the join server. That's the fundamental idea here, that keys should stay in secure environments, especially the root keys, and that you should always make sure that they do not travel in plain text.
Got you. Thank you. Yeah, I think that's something that took me a little while to understand as well, is the difference between root keys and session keys. So now I understand that root keys are used in over-the-air activation, and then those root keys are used to negotiate session keys between the device and the network. And that gives you a lot more flexibility, because it means that, for example, if every time a session closes, you create new session keys. And so even if someone were able to somehow listen to one session, you can regenerate session keys. And it also has the benefit that you can then negotiate session keys with any other network. And I know that we had a big, it took a lot of work to move a lot of devices from the old network server, our V2 network server, over to the ThingStack V3. And a lot of that pain of switching network servers can be avoided by using over-the-air activation as well. So I think in any case that over-the-air activation is possible, it's much more secure, much more scalable, and yeah, it makes your deployment much more future-proof. Okay, so I have written down here as a topic back-end security. Why is back-end security so important? Things like TLS and using firewalls.
Those are general security practices that are important for any kind of information security business. So, for example, in the case of gateways, the gateways themselves are quite an important part of LoRaWAN. They are transparent devices, so they just listen to packets that are sent over the air and then forward them to the network server. In that sense, there is no pairing process. They can hear any packet. Maybe there is a bit of filtering, but in general, the processing occurs in the network server. It is very important that you make sure that all of your gateways are secure, because if you leave ports open, if you don't take care of those things, you may have a supply chain attack at hand. So your personal gateway it may not be up to date. Depending on the software, it could have old software on it. There could be particular security issues with the software running on the gateway. And since you were not careful enough to, let's say, use a firewall, change the default ports perhaps for things like SSH access, now you could actually have a problem because your gateway has been compromised, and you basically may no longer receive traffic from that location. The security of your LoRaWAN frames is not going to be affected by this issue. As you mentioned during your presentation, the packets which are on the air and also transported by the gateway are encrypted with a network session key. So in that regard, they are safe, but your availability can suffer. So for example, take a gateway that is very much used. It provides coverage to a lot of end devices, but you don't have redundancy. It's the only gateway for a particular area. If that gateway gets affected, suddenly you've lost traffic for potentially tens to hundreds of devices. So it's really important that you take this operation security seriously and make sure that your gateways are properly secured.
Okay, so making sure that your gateways are secure maybe does not have a direct impact on an attacker's ability to read messages, but it can affect the availability of your network. That's good to know. So I think you said that tips are making sure that your gateway is up to date, I know that changing default passwords is important, because then if somebody can access your local network, they could potentially take your gateway offline. And so, yeah, so a lot of standard web security practices, I think, apply in this case.
Yeah, I can fully understand that maybe it sounds obvious when you hear it. It's definitely obvious advice, but it's not common occurrence, actually. So there are still end devices that still would benefit from those security practices being respected, which is why we always hammer them in.
Gotcha. So we're going to transition over into discussing some LoRaWAN security myths. Thanks, Adrian, for all your help so far. Adrian, for anybody who doesn't know, is a stack engineer at The Things Industries, and he's been working on the back end of the Things stack for a really long time. So we are grateful to have him here to share his long-acquired LoRaWAN expertise. While we're here, I want to make take one more chance to mention the Things conference in September. So this webinar is part of a series of events that we'll be doing all year, leading up to the Things conference, which is the world's largest LoRaWAN conference. And thousands of guests come every year to Amsterdam to hear hundreds of speakers talk about all of the latest and greatest in LoRaWAN technology. And this year, as part of the whole conference series, we're concentrating on digital transformation. And so we're looking especially at cases where LoRaWAN data is directly making it into business processes and is directly improving people's lives that way. So that's my quick plug for the Things conference, and I'm organizing a lot of the content for it, so I'm looking forward to it, definitely. Adrian, what we're going to do now is I'm going to mention some LoRaWAN security myths that I've come across, and then I'll ask you to weigh in on those. It looks like we've got some questions in the chat here. So all of the recordings of the webinars and the 5-minute videos are all available on the Things Network YouTube. And at the thingsnetwork.org/learn, a lot of that information is up as well. Let me see if I can put the URL up. Yeah, so if you head over to the thingsnetwork.org/learn, all of this information is available there. There's also links to the YouTube, links to the forums where you can ask questions if you want to learn more. And of course, there you can sign up to use the ThinkStack Community Edition for free and start building your own LoRaWAN solutions, which is the best way to learn. So, Adrian, if you're ready, I'm going to bring up some of the LoRaWAN security myths that I've heard. The first one is kind of obvious. It's that LoRaWAN is insecure. Maybe there's a little bit of a confusion there between LoRa and LoRaWAN, but what is your take on LoRaWAN is insecure?
By design, LoRaWAN is secure, but you have to keep in mind the environment in which those devices operate. So there are types of cryptanalysis in which you can look at, for example, the length of a message and say, okay, because it has this particular length, we actually know what is said inside. So we cannot actually access the plain text. We cannot see the temperature, but we know that the message is a temperature message. Or due to the size of the message, we know perhaps if the light is turned on or off, the light that we are monitoring. But outside of those type of attacks are something that can be dealt that are not really important for the kind of metadata that is transmitted over LoRaWAN. So while a LoRa frame is encrypted, the frame counter is also taken into account. So for example, if you have a static temperature of 10 degrees Celsius, Fahrenheit, whatever, and you put it in one message, in the next, it's going to get encrypted to a particular byte. And if you send exactly the same data on the next message, it's going to look completely different. So the frame counter matters. You cannot actually see, okay, each individual message looks the same and do cryptanalysis on that. Fundamentally, LoRaWAN is secure, but supply chain is also very important. So you have to make sure that your root keys have been taken care of, so they've never left the joint server, they haven't been transported in insecure transports and so forth. In general, it's far easier to attack the supply chain than it's actually to attack the cryptographic aspect of the network encryption.
Okay, I think that kind of leads to the next myth, which is do all devices follow LoRaWAN best practices?
In practice, no. In practice, not all LAN devices follow the LoRaWAN best practices because the standard itself is an evolving document. The adoption of newer versions of LoRaWAN, it's complicated. It takes time for the software stacks that run both on the network server and on the end device to mature over time. So not all of the end devices that you might actually end up working with are going to be compliant, or at least to follow the best practices. But newer releases, some which have been manufactured in recent times are in a far better shape than they were, let's say, 3-4 years ago. So the technology itself has matured a lot over time, both from a technical, let's say, performance point of view, and also from a security point of view. It's very good that now we get to have those discussions about the supply chain, about root keys, about joint servers, which were not really seen as important back in the early days of LoRaWAN.
I see. Yeah. So I guess some of the obvious things that device makers can do are use a joint server and securely provision root keys. I know I saw some mention of in really insecure implementations, device manufacturers may be reusing keys or not using keys that are not random, which are all potential attack vectors. It is important that all steps in the supply chain are also secure, and it matters where you get your devices.
Yes.
And I also have written that LoRaWAN is secure even with bad implementation, which I know is a myth. So if you can explain maybe some of the really simple things that people can do to make sure that their LoRaWAN implementations are secure.
Keep your software stacks up to date. So This is complete. I fully understand that for devices which are in the field, firmware upgrades are actually can be a huge hassle. So if you have large volumes of end devices in the field, it will be hard to reprogram those end devices to and to generally bring them to newer software versions. With that being said, as the volumes grow, as you have to deploy more and more end devices, it pays off massively if you make sure that before you put the end device in the field, it is updated with the latest versions of firmware and so forth. So it's important here to make a distinction between the end devices that you buy off the shelf, and you maybe receive a program or you receive a bin file, and you have to flash it, and then you have to make sure that you are using the last version provided by your manufacturer. So that's one side, and on the other side, if you are developing your own LoRaWAN solution, your own LoRaWAN devices, always make sure that you're using the latest versions of the LoRaWAN stack. So things like LoRa Node or other software stacks, make sure that you are as close as possible to the latest version, both for security measures and also for compliance with the standard itself.
Okay, thanks, Adrian. For anybody who's just joining, this is Adrian, who is a stack engineer at the Things Industries and has been working on the Things stack backend for quite a long time. So he's sharing his expertise about LoRaWAN questions and myths. At the end here, I would love to go through and see if we have some questions in the chat that we can address. It looks like there are some questions about different LoRaWAN versions. Adrian, can you comment at all about what the difference, maybe security-wise, in different LoRaWAN versions is and how that would affect end users?
LoRaWAN 1.1 introduced some security features which are strongly designed around active roaming. This is something which hasn't seen as much adoption as the passive roaming that Packet Broker provides. So right now, the market puts a lot of emphasis still on LoRaWAN 1.0.x version, so 102B, 103, 104. Those are the ones which see lots of volume in production. But security-wise, those versions are secure as well. So it's still perfectly valid and safe to use the 102B version and device. It would be great if the push towards 1.1 would grow, then this would basically make sure that the software stacks used by the end devices are also up to date. Because right now you could use a rather old version perhaps of those stacks instead of a newer one, and moving towards newer version ensures that you are not running old vulnerable code. But in general, I would say that the biggest problem with 1.1 right now is adoption. So most of the end devices that I have seen being released are 1.0 version. So 102 and 104, I've seen a couple of them. 1.1 is rare. It is supported by the major LoRaWAN stacks, but I haven't seen many devices on the market. Everyone can do their job with 1.0 just fine for now.
Okay, I see. And you mentioned roaming. It looks like somebody asked a question about the use of AVP versus OTA in rapidly changing radio environments. So he says the tracking of cars, bikes, etc., I guess in which a device would communicate with different gateways might be a case in which OTA is difficult. What do you think about that?
Well, in general, downlink traffic is slightly complicated when you have this movement. So moving as you have the end device moving towards between 2 points, let's say throughout the city, the uplinks are going to be heard by different gateways, and it can be indeed the case that maybe the accept message of the OTA protocol is not going to be sent through the right gateway and not be heard through by the device. With that being said, the idea is not that the end device would rejoin or at least will not rejoin that often. So sessions, the end device must be really, really sure that it doesn't have any link available. So basically there is no communication it doesn't hear the network server before it actually ends up rejoining the network. you can do OTA while in movement. Is going to be hard, but at the same time, if you go the ABP route, so let's say, okay, you have a problem, you don't want to use OTA because you would like to have the same session forever, you are basically baking in those keys into the end device, and officially by the time you have used the full frame counters of the end device, you're supposed to never use those session keys again, which is something that does not happen in practice. In practice, what happens is that they reset the end device, the frame counters get reset, the keys stay the same, and basically it's possible to do cryptanalysis on the session. So fundamentally, as much as possible, even if the radio environment is complicated, you should still steer towards OTA if that's an option.
Well, what is it about these environments that makes OTA so difficult?
Well, keep in mind that while your join accept, so how does OTA work? The end device generates a join request and broadcasts it. It may be heard by a number of gateways, and then the network server takes this join request, verifies, okay, I know this end device, contacts the join server and asks, hey, the join server, is the join request valid for this end device? Join server decides, okay, it is. Network server receives this response, and now it has to decide where it's actually going to transmit the accept message to. Basically, tell the end device, hey, I have accepted your request to join the network. What can happen is that basically you are sending the message through a gateway from which the end device is already far from. But again, this happens in about 5 seconds. So the join delay, it's 5 seconds from the request transmission. If in 5 seconds you manage to get out of the range of your best gateway, your whole link has problems anyway, as in the end device is not going to, it's going to have issues receiving downlinks in general if you cannot for 5 seconds actually maintain range with the same gateway.
Got it. Okay. Let's see if we have any other questions here in the chat that we can address. And I'll make one more plug. This webinar is part of a series of webinars that we'll do all year on various LoRaWAN topics. And all of this leads up to the Things Conference in September, which is the world's biggest conference on LoRaWAN, where we've got thousands of guests coming to hear hundreds of speakers talk about all of the latest and greatest in LoRaWAN. And this year we're focusing on digital transformation. And so here in the meantime, we're trying to educate as many people as possible about LoRaWAN. Let's see, we have a question: how to make sure an end device that's purchased off the shelf is safe? Is there an overview on manufacturers that are reliable?
The things industries can provide some advice when it comes to this. In general, it's good to look at this is a question that you have to ask about every part of your procurement process at the end of the day. So you have to make sure that your gateways come from a reliable source, your end devices come from a reliable source. End devices which are certified by the LoRa Alliance are considered to be, for all intents and purposes, compliant with LoRaWAN, first of all. And secondly, you can also look at the reputation of the manufacturers. I don't think that a public list of who is safe or not exists for the best. It would be quite damaging to be added or removed from that list.
But you mentioned LoRaWAN certification, so that is a pretty good stamp that something meets LoRaWAN.
Indeed, it's a stamp that the end device is compliant with a particular LoRaWAN version. And also it's something that shows the commitment of the manufacturer to actually be compliant with LoRaWAN, and it is definitely something that is almost a requirement before you buy an end device, that it is compliant.
Okay, great. So looks like Ina asked the question, and we would recommend purchasing LoRaWAN certified devices. The LoRa Alliance, I believe, does those certifications, and so manufacturers can submit their devices to have them certified as compliant to LoRaWAN standards. Let's see. Okay, no new questions, it looks like, in the chat. Next week, we have another webinar, and it will be about LoRaWAN networks, roaming, and peering. If you look in the chat, there's a link where you can sign up, so you can join that webinar. And of course, at the end, we always try to answer questions and help people to learn as much as possible about LoRaWAN. Let me see if I have any more topics here. So I don't know how deep we dove into the topic of LoRaWAN gateway security, but I know that Hilke mentioned earlier today that is something that a lot of people overlook in their networks. So what are some things that you can do in order to ensure that the gateway component of your network is secure?
We already mentioned firewalling. That's something that's almost a standard now for LoRaWAN gateways. It's less about, when it comes to gateways, first of all, you have the security aspect that we covered already, but you also have to think about the availability. So a pillar of security is also availability of your service. And something that is really important is that is that in general, one gateway is going to serve many end devices, and it's probably going to be the sole gateway for a particular set of end devices. Those end devices will no longer be able to send and receive messages from the network if the gateway goes down. So what is really important there is that you make sure that you have remote access to your gateway. This is something that is often overlooked, but it's really, really important that you can remotely access your gateway and look through logs, do remote firmware updates, and so forth. This is very important for the availability of your system. And secondly, something that we always recommend is using the basic station packet forwarder and protocol in general. The classical LoRaWAN gateways generally come with something that is known the UDP packet forwarder, in which the frames are sent over UDP between the gateway and the network server. The reliability there is as reliable as UDP is. There are no retransmissions and no checks whatsoever for the messages which are sent. And the messages are just sent in plain text. Whereas with basic station actually ensures that the gateway is authorized to actually send those messages, and we also have the session between the gateway and the network server is encrypted with TLS 1.1 or 1.2. Sorry. So okay. It adds more security and also ensures that the gateway itself is authenticated while transmitting those messages, and this is important.
Got it. So use basic station, use standard web security practices like firewalling the gateway, make sure that you update default passwords. And yeah, so I think that those are a few ways that you can make sure that your gateway is a secure part of your network. And if you don't understand what the difference between a UDP gateway and a basic station gateway is, then we definitely recommend going over to the documentation. On the things stack documentation, we actually have instructions for adding lots of different gateways using LoRa basic station to the thing stack. So the URL is down there. And let's see, we have a question in the chat about root keys. So what are root keys? How are root keys stored? And how do users use root keys to create secure LoRaWAN networks?
Root keys are are literally the root keys used by the LoRaWAN protocol. So if we were to use the same encryption keys directly, we would have ABP. Basically, we always have the same key that is known by the network server and that is known by the end device. We have the same key. We have the encrypted text. Since we share the key, it's symmetric and cryptography. You just, both parties can decode the message. The problem, as we went before, is that those keys basically would persist between networks, and you have security disadvantages that come with that. So what the concept is when it comes to session is that you have a pair of keys which both parties share, or in the case of the secure element actually are not are ephemeral, and basically we decide, okay, we both know those root keys. Here is some information that allows you to derive the session keys for this particular session that we're starting right now. And from this point forward, we are not going to use the root keys at all. We just use the session keys. The root keys are indeed going to be stored by the joint server and by the end device. And then we use them only for this transaction in which we agree upon the session keys and nothing else. And the idea is that even that even if the session key somehow would be the session keys would somehow be revealed to an attacker, or in general, future sessions are still safe, previous sessions are still safe, and root keys are still safe. So the advantage is that even if your session keys somehow get out there, your future and past communications are not going to be affected by it.
Okay, yeah. So root keys live in the device and then need to be communicated somehow. And so the safest way to do that is using a join server, in which whoever manufactures the device also puts those root keys in the join server. And then the join server generates session keys. The device generates session keys. The join server shares those with the network. And then you have secure communication in which the root keys are still, the network does not even have access to the root keys. So somebody asked about experimenting with secure elements and dedicated join servers. Do you have any recommendations about how to do that?
The generic node. The generic node is a secure element enabled device, and we have both the firmware for the generic node is open, so one could look into how the implementation is used there, first of all. And you could also take a physical device and flash it. So the firmware is available, the hardware is soon to be available to be ordered, and then you can use the firmware that we have posted on GitHub to toy a bit with the secure element. LoRaWAN node itself, the software, one of the software stacks for LoRaWAN, has code available for the secure element in case someone is interested in checking how the actual firmware is written there. Experimenting, I would say the fastest experimentation way is by acquiring a generic node.
Okay, and how does somebody go about provisioning devices using a secure element?
Claiming. So in the case, while you will receive a generic node, you will receive also instructions on how to claim the generic node, and this gives you access to basically gives you access to the end device on the things join server, and allows you to see how basically this, what is called interoperability, occurs, and your device joins the network without the root keys ever being revealed. They are not even the end device has access to them. Only the secure element, the secure chip inside, has access to the root keys.
Understood. Okay. Let's see, anything else in the chat? Where does the join server exist? Somebody asked about the architecture of a LoRaWAN network. So we have end nodes, gateways, network, and the app server. Where's the join server?
Join server sits somewhere a bit between, sits peripheral to the network server and application server. So it can be an external service provided by an external party. So for example, the common use case is that the device manufacturers have their own join server. And then when you add your device to a particular network, the network has an agreement with the join server. Hey, all of those join requests that have this particular join UI, we're going to send to you. The join server receives then does this protocol, and we have a session without the root keys ever leaving the join server itself. So if you imagine the line, so you have end device sends message, let's say, to gateway sends it to network server decrypts one layer of the onion, sends it to application server, removes the last layer, and now you have the plain text, the temperature, let's say that's the text that we're sending. Both the network server and the application server can get the session keys from the join server. So the join server is the service which actually provides you with the session keys in case you need them.
Okay, so the join server sits kind of in parallel in this network, and both the network server and the application server can communicate with the join server in order to get session keys so that the root keys are preserved. And I know that one other advantage of a join server is that then, since the root keys are never shared with the network, it's very easy to switch networks. So in the future, if you think you're going to be maybe changing something about your LoRaWAN network, then a join server also provides an additional layer of functionality. And if you missed the onion analogy that Adrian made, at the beginning we shared a 5-minute video about LoRaWAN security. So I tried to compress as much information as possible into that 5 minutes. It's very fast, but it's up on our YouTube. And then all of that information is also available on the Things Network Learn section. So if you head over there's lots of information all about LoRaWAN And there you can also get started using the Things Stack Community Edition for free. Unless we have any more questions, let me check the chat really quickly. Okay, it looks like we're about ready to wrap up here. I don't see any new questions. I'll just make one last, well, first I have to say thank you to Adrian. Adrian is a stack engineer at Things Industries and has been doing backend architecture on LoRaWAN network servers for quite a while. So thank you, big thank you, Adrian, for coming and sharing your insights about how people can make their LoRaWAN networks more secure, about the fundamental security of LoRaWAN, about potential shortcomings in implementations. And we've learned quite a lot from you. So thank you again. The recording of this will be up on our YouTube for anybody who wants to catch up later. And I think I'll let you go, Adrian, and then I'll just say thank you to everybody and goodbye.
Thanks everyone for having me. Have a nice day.
Anytime. See you, Adrian. All right. So we're going to wrap up here. For anybody who is interested in continuing to learn, of course, there's the Things Network Learn, and if you have any commercial questions about using the Things Stack, head over to thingsindustries.com. There we have documentation about how to use the Things Stack, and also we have we offer private SLA-backed network servers for enterprises, and yep, I think I've covered all the questions. We're always reachable, and we're looking forward to seeing what you build with all of your new LoRaWAN information. Adrian mentioned the generic node. That's a really, really cool device for prototyping your LoRaWAN solutions. The Things Industries, like I said, we offer, we have the Things Stack Community Edition, which is a free-to-use network server. If you head over to thingsnetwork.org, you could sign up there. But then once you're ready to scale commercially, the Things Industries has cloud-based and enterprise, so local deployment, private LoRaWAN network servers that are ready to scale to up to millions of devices. I want to say one last big thank you to everybody. And of course, I hope that we'll see you in the future at more webinars, and then at the Things Conference in September in Amsterdam, where we'll have thousands and thousands of IoT professionals coming together and hundreds of speakers to talk about the latest and greatest in LoRaWAN. I'm Ben, I'm the technical writer at the Things Industries, and I'm saying a last thank you and goodbye. See you everybody next week at the next webinar on network.